Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry degree level, chapter hyperbolic functions, lecture number 1, in which I will introduce about hyperbolic functions. Let Z be a real or complex number. Then hyperbolic sine and hyperbolic cosines of Z are denoted by sin h z and cos h z respectively, and sin hz equal to e to the power z minus e to the power minus z by 2, cos hz equal to e to the power z plus e to the power minus z by 2. This is number 1. This is number 2. This expression is called hyperbolic sine of z, and this expression is called hyperbolic cosine of z. Since we know that sin theta equal to e to the power I theta minus e to the power minus I theta by 2I, and cos theta equal to e to the power I theta plus e to the power minus I theta by 2. This is number 3. This is number 4. Replacing theta by Iz, we get sin Iz equal to e to the power I in place of theta Iz minus e to the power minus I in place of theta Iz by 2I, and this equal to e to the power I square means minus 1 minus z minus, here I square is minus 1 and minus, plus e to the power z by 2I, and this is equal to, we take common minus e to the power z minus e to the power minus z by 2I minus 1 here. Minus 1 means I square e to the power z minus e to the power minus z by 2I, and this is equal to I 1I cancel, remains 1I e to the power z minus e to the power minus z by 2, and this is equal to I, and from 1 this is hyperbolic sine of z, sine hz. This is number 5. This is the relation between circular sine function and hyperbolic sine function. Replacing theta by Iz in 4, we get cos Iz equal to e to the power Iz plus e to the power minus Iz by 2. This is I square means minus 1 e to the power minus z plus here I square is minus 1 minus plus e to the power z by 2. So this is hyperbolic cosine function of z, cos h z. This is number 6. This is the relation between circular cosine function and hyperbolic cosine function. 5 may be written as, here we keep sine hz and I goes left side, 1 by I sine Iz. Here we may write 1 as minus I square sine Iz by I square is minus 1 minus plus 1 and this will be equal to minus I sine Iz. This is number 7. From 6, hyperbolic cosine z cos hz equal to cos Iz. This is number 8. So we get sine Iz equal to I sine hz cos Iz equal to cos hz sine hz equal to minus I sine Iz cos hz equal to cos Iz, and we have to remember these formulas. Since hyperbolic sine z equal to e to the power z minus e to the power minus z by 2 and hyperbolic cosine z equal to e to the power z plus e to the power minus z by 2. Therefore, hyperbolic tan z equal to hyperbolic sin z by hyperbolic cos z, and this will be equal to e to the power z minus e to the power minus z by e to the power z plus e to the power minus z. Hyperbolic sec z will be 1 by hyperbolic cos z, and this will be 2 by e to the power z plus e to the power minus z. Hyperbolic cosec z equal to 1 by hyperbolic sin z. This is 2 by e to the power z minus e to the power minus z, and hyperbolic tan z equal to hyperbolic sin z by hyperbolic cosine z, and this is equal to hyperbolic sin z is minus I sin Iz by this is cos Iz, and this is equal to minus I tan Iz. Hyperbolic sec z equal to 1 by hyperbolic cos z, and this is equal to 1 by cos Iz equal to sec Iz. Hyperbolic cosec z equal to 1 by hyperbolic sin z, and this is equal to 1 by minus I sin Iz, and this is equal to minus I square. 1 means minus I square by minus I sin Iz, and minus minus cancel, 1 I cancel, only remains I 1 by sin Iz. This is equal to I cosec Iz. These are the formulas which will help to solve the problems of this chapter. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.